performance out here has been nothing but sensational.
One, the International Space Station. Let's kick things off with the absolute juggernaut, the International Space Station, or ISS. Built as a joint project among NASA, Roscosmos, ESA, JAXA, and CSA, it's the most expensive man-made object ever constructed. Launched in 1998 and continuously inhabited since 2000, the ISS cost a staggering $150 billion, a sum that includes hardware, launch costs, maintenance, transportation logistics, and years of international collaboration among over 15 nations. This cost doesn't even account for the future spending on upgrades, research, or additional missions. Why so expensive? Imagine creating a floating science laboratory the size of a football field, orbiting 250 miles above Earth, with astronauts living on board for months at a time. Every single component, from oxygen filters and water recyclers to robotic arms and solar panels, must not only function flawlessly in microgravity, but must be able to withstand the harshest environmental conditions of space. Logistics alone are mind-boggling. Dozens of launches from multiple countries were required to ferry parts and modules to space. Precision docking, on-orbit assembly, life support systems, navigation controls, scientific payloads. It's like building a self-sustaining city in space. But the ISS is more than just an engineering marvel. It has served as a microgravity lab for thousands of experiments, ranging from cancer research to water purification technology. The benefits of the ISS ripple far beyond the realm of space travel, influencing innovations in medicine, agriculture, and even consumer tech back on Earth. It's not just a space station. It's a floating emblem of what humanity can achieve when united by science. Second Large Hadron Collider. Beneath the tranquil French-Swiss countryside lies one of the most ambitious scientific instruments ever created, the Large Hadron Collider, LHC. Operated by CERN, this enormous underground ring stretches 17 miles in circumference and is designed to smash subatomic particles together at speeds approaching the speed of light. Its purpose? To uncover the very building blocks of the universe. Constructing the LHC was a feat of engineering that involved over 10,000 scientists and engineers from more than 100 countries. The cost? Over $10 billion, and that's just a baseline figure. Here's why it's so expensive. The LHC uses an array of superconducting magnets cooled to negative 271.3 degrees Celsius, colder than deep space. The complexity of the cryogenic systems alone, needed to maintain this ultra-low temperature, would dwarf the infrastructure of many small cities. Every collision inside the LHC replicates conditions not seen since the first microseconds of the Big Bang. The 2012 discovery of the Higgs boson, the so-called God particle, was hailed as one of the most significant achievements in modern physics. But it's not just about fundamental particles. Research at the LHC also influences breakthroughs in medical imaging, radiation therapy, data science, and computational models used across industries. The LHC is a $10 billion microscope pointed at the very soul of the universe. Third James Webb Space Telescope. Launched on Christmas Day 2021, the James Webb Space Telescope, JWST, represents the pinnacle of human optical engineering. Costing $10 billion and more than 20 years in the making, the JWST is positioned 1.5 million kilometers away from Earth, beyond the reach of traditional servicing missions. Its 21-foot-wide gold-coated mirror, made of 18 hexagonal segments, that unfold with millimeter precision. The telescope's 5-layer sun shield, each thinner than a human hair, protects the instrument from heat and light contamination. Unlike its predecessor, Hubble, which focused primarily on visible and ultraviolet light, JWST specializes in infrared astronomy. This means it can peer through cosmic dust clouds to observe the formation of stars and planets, detect heat signatures from exoplanets, and even analyze the atmospheric composition of distant worlds. The JWST is so sensitive it could detect the heat of a bumblebee on the moon. Imagine the precision required for that. And now imagine it functioning flawlessly from a million miles away. Already it has has reshaped our understanding of the universe, sending back images of galaxies formed just 300 million years after the Big Bang, and raising questions about the nature of dark matter, galactic evolution, and cosmic inflation. It's not just a telescope, it's humanity's time-traveling eye into the cosmos. Czwarty USS Gerald R. Ford Letadlowa Lodge. Welcome aboard the most technologically advanced warship in human history, the USS Gerald R. Ford. This floating fortress cost the U.S. Navy an estimated $13.3 billion, not including the air wing or lifetime operational costs, which can push the total beyond $30 billion. Why so pricey? The ship is a complete overhaul of aircraft carrier technology. It includes electromagnetic aircraft launch systems, EMALS, replacing the traditional steam catapults for launching planes. This not only saves weight in space, but allows for faster, smoother, and more frequent launches. It's powered by two Bechtel A-1B nuclear reactors, giving it enough energy to power a small city and to stay at sea for 20 years without refueling. Then there's the radar system, a multi-function dual-band radar suite that can track hundreds of targets simultaneously. Automation reduces crew requirements, which over time will save billions in operating costs. At full capacity, the Ford class can carry more than 75 aircraft, including FA-18 Super Hornets, MH-60 helicopters, and even future F-35 jets. It's a mobile airbase capable of reaching any part of the world within days. The USS Gerald R. Ford isn't just a war machine, it's a floating demonstration of American technological dominance. Number 5. ITER Fusion Reactor. Now let's talk energy, real energy. The International Thermonuclear Experimental Reactor, or ITER, is a bold bet on the future of power. Its mission? To make nuclear fusion, the same process that powers the sun, a reality here on Earth. With an expected cost of over $25 billion, ITER is being built in southern France through a global partnership of 35 nations, including the EU, China, India, Japan, Russia, South Korea, and the US. Fusion, unlike fission, doesn't create long-lived radioactive waste or carry meltdown risks, but it requires heating plasma to over 150 million degrees Celsius, 10 times hotter than the core of the sun. To contain this plasma, ITER uses massive toroidal magnets, each weighing hundreds of tons, suspended within a vacuum chamber made of ultra-strong materials. The infrastructure required to manage this environment, cooling, shielding, fueling, and maintaining equilibrium, makes ITER one of the most complex machines ever built. If successful, ITER could provide the blueprint for reactors that generate virtually limitless, clean energy, ending our dependence on fossil fuels and changing the energy landscape forever. It's an expensive dream, but one that may define the next century. Number 6. The B-2 Spirit Stealth Bomber. The B-2 Spirit Stealth Bomber is one of the most iconic and mysterious aircraft in modern military history. With a unit cost of approximately $2.1 billion, it holds the title of the most expensive aircraft ever built. Only 21 were produced, and each one is a marvel of aerospace innovation and strategic defense design. So what makes the B-2 Spirit so expensive? For starters, its unique flying wing design gives it an exceptionally low radar cross-section, allowing it to penetrate deep into enemy territory undetected. It can carry both conventional and nuclear weapons, and it has a range of over 6,000 miles without refueling, nearly double that with aerial refueling. But stealth isn't cheap. The B-2 is coated with radar-absorbing materials that require constant maintenance. Even slight damage to the coating can compromise its stealth profile. The avionics systems inside are classified, featuring cutting-edge targeting and navigation capabilities that were decades ahead of their time when the plane first flew in 1989. Maintenance alone for the B-2 is notoriously complex. Each aircraft demands thousands of hours of labor annually to stay mission-ready. And because of their limited number, parts are specially manufactured and upgraded continually, often costing millions per piece. Beyond its military role, the B-2 is a symbol of deterrence, dominance, and technological supremacy. Number 7. The Hubble Space Telescope. Before the James Webb Space Telescope, there was Hubble, the trailblazer that changed the way we understand the universe. Launched in 1990 aboard the Space Shuttle Discovery, the Hubble Space Telescope initially cost about $1.5 billion. However, after several critical servicing missions and upgrades, the total cost has ballooned to over $4.7 billion. The mission of Hubble was straightforward but revolutionary: deliver crystal clear images of the cosmos from outside Earth's atmosphere. But soon after launch, a flaw in the main mirror created blurry images. It was a near-catastrophic error until astronauts aboard a 1993 space shuttle mission installed corrective optics, effectively saving the mission and Hubble's reputation. Since then, Hubble has captured some of the most stunning and informative images in scientific history. Pillars of gas where stars are born, galaxies billions of light years away, and even glimpses into the atmospheres of exoplanets. It's been instrumental in confirming the existence of dark energy and refining the age of the universe. Hubble is not just a telescope, it's a floating observatory, a time machine, and a reminder that even flawed beginnings can lead to extraordinary outcomes. Number 8. Skylon Spaceplane. Still in development but already attracting massive attention is the Skylon Spaceplane, a single-stage-to-orbit craft designed by Reaction Engines Limited in the UK. With an estimated development budget of around $15 billion, Skylon represents a new frontier in reusable space travel. Its revolutionary Sabre engine is a hybrid that functions as both a jet engine in Earth's atmosphere and a rocket engine in space. This design could eliminate the need for multi-stage rockets, reducing launch costs dramatically. Skylon is designed to take off and land on a runway like a traditional airplane, but it will be capable of reaching low Earth orbit without the need for booster rockets or jettison stages. This not only makes it more cost-effective in the long term, but also significantly more environmentally friendly. If successful, it could carry satellites, cargo, or even passengers to space at a fraction of the current cost. Though still in experimental phases, Skylon represents a shift toward accessibility and reusability in space travel, a necessary evolution for our future off-world. Number 9. Apple's headquarters. Even corporate architecture can top the charts in tech spending. Welcome to Apple Park, the $5 billion headquarters of Apple Inc., located in Cupertino, California. Designed in a perfect circle that spans 1.6 kilometers in diameter, it has been nicknamed the Spaceship Campus, and for good reason. Designed by the legendary architect Norman Foster in collaboration with Steve Jobs, Apple Park is a combination of futuristic minimalism and sustainable innovation. The main building alone contains curved glass panels, so large and flawless that Apple had to custom manufacture them, the largest of their kind in the world. It runs on 100% renewable energy, mostly provided by solar panels blanketing the entire roof. The campus features extensive green spaces, walking paths, and a man-made pond at its center. Inside, it's a seamless environment designed to foster creativity, collaboration, and cutting-edge development. From the underground, 1,000-seat Steve Jobs Theater to the $17 million custom-designed door handles, every element of Apple Park is engineered with the same obsessive attention to detail as an iPhone. Apple Park isn't just an office, it's a living monument to the fusion of design, innovation, and ambition. Number 10. The Manhattan Project. The final entry is as sobering as it is monumental. The Manhattan Project was the secret U.S. military program initiated during World War II to develop the atomic bomb. Adjusted for inflation, the project cost about $23 billion, making it one of the most expensive and impactful tech efforts in human history. It involved more than 130,000 people across dozens of sites in the U.S., UK, and Canada, including facilities in Los Alamos, Oak Ridge, and Hanford. The project was shrouded in secrecy and operated under immense time pressure, driven by fears that Nazi Germany might develop nuclear weapons first. The scientific breakthroughs achieved were staggering. The development of nuclear fission, reactor design, uranium enrichment, and the eventual creation of the bombs dropped on Hiroshima and Nagasaki. These milestones not only ended a world war, but ushered in the nuclear age. However, the cost wasn't just financial. The ethical ramifications and human toll of nuclear warfare have haunted global politics ever since. The Manhattan Project is the perfect example of how some technologies, however advanced, carry immense moral weight. It remains one of history's most extreme illustrations of what can happen when science, war, and urgency converge. From war machines and space observatories to fusion reactors and billion-dollar campuses, these technological marvels represent the highest stakes in human innovation. Each invention came with a staggering price tag, but also with the potential to change everything. Whether it's solving the mysteries of the universe, redefining energy, or raising ethical questions that echo through history, these creations prove one thing. When humanity dreams big, the cost may be high, but the impact can last forever. Which of these inventions shocked you the most? Thanks for watching. Stay curious.